Hi students, all of you welcome. Welcome to Sunil Engineering Academy. I am Sunil Kumar Bandaru. Students, in this general science physics, we have already completed 3 sessions. It is the fourth one. These sessions are useful for all your competitive examinations. And let me check up to which we have completed. We have completed the topic charge, Coulomb's laws, electric current, resistance, resistivity, conductivity, conductance, potential, that is voltage, Ohm's law, series combination, parallel combination, inductor, capacitor. Okay, so up to this one we have completed now. So now we are going to discuss electric power, heat and energy. Okay. So electric power. Okay, so what is the power? We can denoted the electric power as P. Power is equal to product of voltage into current. Power is equal to product of voltage into current. So this is the first formula of the power. And we know voltage is equal to current into resistance as per the Ohm's law. Substitute that in the equation 1. Then power is equal to, in the place of voltage, I into R into I. So you will get power is equal to I square into R. So this is the second formula of the power. And from this Ohm's law, we can also substitute the with I. I is equal to V by R. Substitute this in the equation 1. From equation 1, power P is equal to V into, in the place of I am substituting V by R. So then what is the formula you will get? V square by R. This is the third formula of the power. From this one, we can say whenever they have given voltage and current, we go with this formula. If they have given current and resistance, we can go with this formula. Whenever they have given voltage and resistance, we can go with this formula. Okay, so power is equal to generally product of voltage and current. And the units of electric power is watt. Watt. Or you can also say that kilowatt. Watt or kilowatt. Okay. So note down this one. Electric power P is equal to V into I square R, V square by R. Very important in the numericals. Okay. So if in the questions, if they have mentioned as load, load is nothing but this is also load power. Okay. Power consumed. Don't confuse. Load is also denoted with the watt or kilowatt. So power also watt or kilowatt. Don't confuse. After this, electric energy. Electrical energy. So note down the electrical energy. Electrical energy. So energy is nothing but power into time. Power into time. Okay. So if you have consumed the power within this particular time, then you have consumed that much of electrical energy. Power into time. Okay. And the units are watt into second. This is nothing but you can say watt into second is nothing but second, or kilowatt into hour. So generally we denote with kilowatt hour. Okay, so the unit of electrical energy, unit of electrical energy is given in kilowatt hour. So that equivalent of joule seconds, 1 kilowatt hour is equal to 1 kilowatt means 1000 watts. 1 hour is equal to 3600 seconds. and 1 watt second is equal to 1 joule. So from this one, 36 into 1, 2, 3, 4, 5, 5 zeros, 10 power 5 watt second. Watt second is nothing but joule. So I am going to take here point 3.6 into, if you take point here, you will increase 10 power 6. Watt second means joule. So 1 kilowatt hour is equal to 3.6 into 10 power 6 joules, or 1 kilowatt hour is equal to 3.6. 10 power 6 means mega joule. So you have to remember this one. Very easy to remember. 1 kilowatt hour is equal to 3.6 mega joules. Okay, generally we are calling, that is, we have consumed 100 units, 200 units, 300 units, like that. What is the unit? 1 unit, our commercial unit. 1 unit is nothing but 1 kilowatt hour. 1 unit is nothing but 1 kilowatt hour. So if we have consumed 200 units means 200 kilowatt hour. Okay. So note down this one. Note down this one. And in the same way, we have 1 kilowatt is equal to, in the mechanical terms, that is power, electric power in terms of the mechanical. So let us take that one in the previous slide. Okay, here 1 kilowatt is equal to 1 horsepower is equal to, it is better to remember like this, not in kilowatt. 1 horsepower is equal to 746 watts of the electrical power. 746 watts of the electrical power. It is also very important. Remember this. So electrical energy. Okay. Now coming to heat energy. Heat energy by electric power, or you can say heat effect of electric current. Heat effect of electric current, or heat energy. Heat energy. If you can consider, whenever we have a conductor having some resistance R, whenever the current flowing through the conductor, then due to power consumption, that some amount of the heat is generated. That some amount of heat is generated. That heat energy is equal to, heat also energy na, heat energy is equal to power into time. Power is equal to I square R into time. So the heat energy is generally depends upon current. So whenever there is a more current, as the current is more, heat energy will be more. Heat energy is more. Okay. So very, very important. Sometimes they will ask a question on heat. Heat is equal to I square R into T. I square R into T. T is nothing but time. We know we are using the electric fuse. Fuse. Fuse depends on this heating effect. Fuse depends on heating effect. Heating effects. Okay. So here why we are using this fuse? To protect the device. To protect electrical device or electrical appliance. Electrical device such as motor, AC, okay, so or any other loads. How we can protect? By using the fuse. For example, if you have the applied voltage, here we have connected one fuse to the motor. So the current, that is here the connections through the fuse and then motor. So whenever you have applied the voltage, then current is flowing now. This current is flowing through the fuse. After that, it is flowing through the motor. Whenever the current is more, very high value than the normal value, okay, very high value, then what will happen? Heat produced will be I square R into T. As current is more, heat produced will be more. Due to this heat, the fuse melts. The fuse melts. Whenever the fuse is melt, for example, if the fuse is melt like this, then there is no current is flowing now. Whenever there is no current flowing through the motor, means motor is safe. Motor is safe. Okay, so like that the fuse protect the device. Okay, so fuse melts, device is safe. Device is safe. Okay, so like that fuse works. Like that the fuse works. So what is the principle behind the fuse? That is heating effect of electric current. Heating effect of electric current. And the main requirement of fuse is main requirement of fuse is low melting point. Low melting point. And if you can consider resistance, high resistance. Low melting point is our main requirement of the fuse. Okay. If it is not melt, then what will happen? Then still current flowing through the motor, motor is going to be damaged. So that's why the materials like tungsten, carbon are not used as the fuse. Okay, so generally we can use the fuse wires as some leads of the copper or lead or silver, like that. Silver is the best fuse element. Okay, so carbon, tungsten are not at all used as a fuse element. Why? Because they have high melting point. So high melting point materials may not be used as the fuse. Note down this one. High melting point materials not used as fuses. Example, tungsten, copper, like that. Okay, and generally the fuse materials are generally copper, silver, lead plus copper, like that. Okay, so these are the generally used as the fuse materials. And fuse rating, generally what is the rating of the fuse? Given in amperes. Fuse rating given in amps. Okay, if they have given 10 amps fuse, means it can be withstand for up to 10 amps. If you have given, if the current is more, that is 20 amps, 30 amps, the fuse is going to be melt. Fuse is going to be melt. Okay, so this is the heating effect of electric current and the fuse. After this, we have to discuss electrical energy completed, heat completed, and electric power also completed now. It's very good. And now we have to take some meters. Let us take the voltage, and that units are volts, and the meter used to measure voltmeter, and its important property, its internal resistance is infinite, ideal case. In case of ideal, very important, ammeter, that is current used units are amps, with that unit name ammeter. Ammeter internal resistance is almost very low, 0. And then resistance, for the resistance units are ohms, and the meters, we have so many meters. I am giving ohm meter, and here one more so many meters are there. These two are important. Megger used to measure the high resistance generally. Okay, high resistance generally. After that, power, electric power, measured by units are watt or kilowatt, measured by watt meter, with the unit name watt meter. Okay, and electrical energy kilowatt hour, the meter name is energy meter only, energy meter only. Okay, so these are the very important. And in the resistance, we have one more device, a variable resistor. A variable resistor is generally called as rheostat. Okay, a variable resistor, the device is called as rheostat. It is a having a long coil with one sliding contact. Okay, long coil with a sliding contact. As sliding contact varies, the resistance is varies. The resistance is varies. Okay, all of you clear? Okay, and some different types of points are important. For example, in case of bulbs, in generally in household purpose, generally bulbs, fans, those are nothing but whatever the bulbs, fans, motors, ACs, all these are considered as generally loads. Okay, so these loads are generally connected in parallel connection. Okay, in parallel connection. In case some decorating purpose, some decoration purpose or advertising purpose, the bulbs are generally connected in series connection. In series connection. Okay. So here two points are important. The first point, in case of parallel. Okay. So in case of parallel, in parallel connection, high rating bulb gives more brightness. Connection, high power rating bulb gives more brightness. For example, if bulb A having ratings are 200 volts and 200 watts, bulb B having 200 volts, 100 watts rating, here bulb A gives more brightness. Okay, we can also understand this one in real time example. In our houses, we have connected bulbs are in the parallel now, so we can understand. For example, nowadays we are using LEDs. 12 watt LED bulb gives more brightness than 6 watt LED, correct? So here also, bulb A gives more brightness. And in the series connection, opposite. in the series connection opposite. Low power rating bulb gives more brightness. Why? Because it consumes more power. Okay, so here that means bulb B gives more brightness. Okay, so these are the bulb based problems. Okay, if any points are missing, those will be discussed in the topic wise MCQs. Okay, so don't worry. So we will discuss those points in the topic wise MCQs. So in the today's session, we have completed electric power, three equations of electric power, electrical energy, heating effect of electric current, fuse, and some meters and bulb based problems. Okay. Yes. In the next session, we will discuss another topic. Another topic is nothing but magnets and magnetism topic. Okay. So, and all of you, please share this sessions to all your friends and also click like button. And if you want to share anything, you can give in the comments. All the students are watching this, but nobody giving the comments. Your comments will encourage me a lot. Okay. And I have given the telegram link in the description box. You can also join in that. Okay, I love you. Thank you so much for watching. Take care. Bye guys.